Okay, so we have another integration by parts question here. Let's let u equal to, okay, so let's think about this. What should we let u be? We have two choices. 1 over root of y or ln of y. Now, if you differentiate ln of y, first of all, it's easier to differentiate ln of y than to integrate it. And if you differentiate ln of y, it becomes 1 over y. So the ln expression disappears. Okay? So that tells me, you know what? Ln of y is a better choice. Okay? If it doesn't work out, maybe we'll have to think about integrating ln of y. But for now, let's stick with u is ln of y. So that means dv is 1 over root of y. So I'm going to write that as y to the power of minus half. Okay? So then du is 1 over y dy. And v is u to the power y to the power of half times by 2. Okay? So by integration by parts, okay, we get 2y to the power of half, multiply these two u and v, ln of y minus, okay, multiply these two now, 2, 1 over y times by y to the power of half, dy. So that's the same thing as, right, half, at the bottom there's 1, so it's minus half again. So one more integration. Okay, so it's actually, technically you should write here, we still have to plug in the initial value that were given, 4 and 9. Okay, if this was a written test, you would have to write that. Okay, and we get y to the power of half here and times by another 2, so I'm going to change that to 4, and in here I had to plug in 9 and 4 as well. Okay, so let's plug in 9. You get root of 9 ln of 9 minus root of 4 ln of 4 minus 4 root of 9 minus root of 4. Okay, we can simplify that a bit. 2 times by 3 ln of 9, 2 times by ln of 4, and this is just 3 minus 2, which is 1. Okay, so let me expand that, and you get 6 ln of 9 minus 4 ln of 4 minus 4. Right, 3 and 4 is actually perfect squares. 3 squared, 2 squared, so you can use the log law to bring these powers down to give you 12 ln of 3, 8 ln of 2 minus 4.